Welcome to this IEA webinar. My name is Gianluca Tonolo, and today, together with my colleague Urszula, we will introduce you to energy efficiency indicators. Let's start with an example of a widely used indicator, the energy intensity. We can see here a figure illustrating the energy intensity trends for different regions since the 80s. The graph gives a lot of useful information, as for example the impressive reduction of the China region energy intensity. And now I have a question for you. Do you think that energy intensity, calculated as the total primary energy supply divided by the GDP, is a good indicator for energy efficiency? I'll let you some seconds to think, and then I'm going to try to give you an answer. Okay. Although sometimes energy intensity is used as a proxy of energy efficiency, this could lead to mistakes. Why? This is because the intensity indicator is a measure of how much energy is consumed in a country to produce 1 unit of GDP. However, the indicator is too high level and includes different factors, such as the structure of an economy, for example, what kind of businesses are more important or less important in the country GDP, besides the real efficiency. To sum up, in order to study efficiency, we need more detailed data. Indeed, with the use of more detailed data, as the one the IEA collects from its member countries, it is possible to study energy efficiency trends more in depth. This figure, for example, shows the results of the IEA decomposition analysis that disentangle the energy consumption in 3 different factors. The activity, that you can see in the blue line, that could be represented, for example, by population or GDP. The structure, for example, the shift from more intense industries to services, and the efficiency factor, so the use of more efficiency equipments, for example. Now I have other questions for you. We'll try to see if our definition of energy efficiency is the same. So I'll give you some cases, and you have to think about if for you these represent energy efficiency improvements. Let's start with the first one. Consuming less energy but providing the same service. As for example, the replacement of incandescent bulbs with LED. Is that an energy efficiency improvement for you? Think about it. I'm going to give you another example, and then I'm going to give you some answers. Is it the consumption of the same amount of energy by providing more service, as for example producing more cement, consuming the same amount of energy, an efficiency improvement? Think about these 2 cases, and if for you represents efficiency improvements. Yes, these 2 examples represent efficiency improvements. If you thought yes, the answer is correct. But now let's see other 2 examples. Consuming less energy because of a change in service, as for example the shift to less energy intensive industries or services in the economy of a country. Or another example, consuming less energy but providing less service. For example, biking or walking instead of driving a car. Think about these 2 examples for a moment, and if for you they represent efficiency improvements or not. To give you an answer, these 2 examples don't represent energy efficiency improvements. Indeed, the first one represents an economic restructuring without any real efficiency actions, and the second, even if it will be beneficial in terms of air pollution and climate mitigation, the service they provide is of a lower quality. For example, an efficiency improvement for the second example would have been using more modern cars. But now let's start the presentation by seeing the overview of what we are going to speak about today. We will see why is developing energy efficiency indicators important. Then we will see what information we can get from energy balances. What additional information are needed to study energy efficiency, so what data we will need. And finally, how we can collect this data. What are the tools we have to collect the data? So let's start with the first part. So why is efficiency important, and why so we need efficiency indicators to study it? So the importance of energy efficiency is not limited at energy savings and greenhouse gas emissions mitigation, but goes from environmental, social, and health benefit to economical and energy security improvements. As you can see from the energy efficiency flower in the slide right now, that lists some of the examples of benefits that energy efficiency actions could bring. Okay. So one of the first visible benefits of energy efficiency improvements is that it contributes to keep energy consumption levels down, directly cutting greenhouse gas emissions. According to the IEA Energy Efficiency Market Report 2016, efficiency improvements since 2000 to the year 2015 saved 19 exajoule of energy consumption. That is enough to power Japan for 1 year. And as you can see from this figure, these energy savings avoided 1.6 gigaton of CO2 in 2015 to be emitted in the atmosphere. Additionally to these benefits, energy efficiency can also reduce expenditure for energy and improve energy security of a country by reducing the need of importing energy products. For these reasons and all these benefits that energy efficiency has, many countries have set energy efficiency targets and plans. And this is why there is a need of information and data in order to monitor and track these plans. But now let's see another interesting slide that shows us that there is still a very high portion of energy consumption that is not covered by energy efficiency policies. And these represent a very big potential for action. Indeed, according to the last year IEA Energy Efficiency Report, still 70% of energy consumption was not covered by efficiency policies in 2015. This is why it is very important to have detailed data in order to be able to study energy efficiency trends in depth, to know, firstly, the priority areas and where we stand, to set the targets, and then to track and monitor the actions. And now let's start from the beginning. What information we already have available from commonly collected data, the energy balances? As you may know, most of the countries collect basic energy statistics on production, transformation, final consumption of different energy products. And they combine these statistics together to build energy balances. Energy balances give a very powerful piece of information and permit, combined with some macroeconomic data, to calculate aggregated indicators. As for example, as we have seen before, the energy intensity, coupling total primary energy supply with GDP, or the energy self-sufficiency. We can also calculate the efficiency of transformation sector, as for example, the electricity generation efficiency, and for example, the share of energy final consumption by sector. However, there are limitations in terms of the disaggregation of the energy data. Indeed, for example, in an energy balance, the residential and the services sector are represented as a total, while in order to study energy efficiency, we will need a further disaggregation by end use of these sectors. As for example, we would like to see in the residential sector how much energy is consumed for space heating, how much for space cooling, lighting, and appliances, and etc. But let's see an example using energy balances data. The pie chart here is showing the United States total final consumption by sector in 2014. We can easily see that the road transportation sector, representing 35% of total final consumption, is the most consuming in the US. So it is probably also a sector that brings a high potential in terms of savings from efficiency improvements. But how do we study energy efficiency improvements in the road transport sector? We will need more data than the one we have in balances. For example, we need to know the consumption by segment, how much of this road consumption is from freight or from passenger transportation, and the different vehicle types, how much energy is consumed by cars, by motorcycles, buses, and trains. And we will need, additionally, to couple this data with activity data that meter the service provided, as for example, the distance traveled or the passenger or ton kilometer. Let's see another example where we study the residential sector trends, starting by using the most aggregated data, so the balances data, to the use of the most detailed ones. If you analyze the residential sector consumption over 20 years, as shown in the graph, in the blue line, we can see that there has been an increase as a whole. However, if we analyze residential consumption per capita, as shown in the red line, we can see that there has not been a significant change in this 20 years period. If you go even further, to use more detailed data indicators, for example, if you analyze the residential consumption in space heating divided by occupied dwellings, or for example floor area, are the lowest two lines in the graph, we can see that there has been a dramatic reduction over this period. So the residential per capita indicator didn't show any change even with the big efficiency improvement we have seen, for example in the space heating, because of increased use of new appliances, for example, smartphones, computers, and tablets. To sum up, the use of high-level indicators can bring to different message than while using disaggregated indicator. So it is very much important to pay attention to the disaggregation of the data used when analyzing energy efficiency. So let's see one other last example in order to bear in mind this concept. This figure shows, in the y-axis, the average annual percentage change of energy intensity between 1990 and 2010 for different countries. Each country represented by a different square in this graph. Let's focus now on country X and country Y. Which of these two countries you think has decreased more in energy intensity? Think about it for a second. If you set country X, you're right. Country X decreased more in energy intensity than country Y during this period. However, I have another question. Is it right to say that country X improved more in energy efficiency? Think about that again. The answer to this question is no, we cannot say that because we will need more detailed data. This is because to study energy efficiency in detail, we will need a disaggregated indicator as the one we have seen in the example in the latest slide. Indeed, country Y, in this example, improved more its energy efficiency level than country X. The higher decrease in energy intensity witnessed by country X was mainly driven by changes in the structure of its economy. For example, a higher share of the less intense service sector in the economy of country X. Now, I'm going to leave the floor to my colleague Urszula that will show you what are the more detailed data that we need to study energy efficiency, sector by sector.
Thank you a lot, Gianluca. In the first part of the webinar, we have seen that we can do a lot with already available data, like the energy balances. Now, let's try to understand what the data may be needed to create more detailed energy efficiency indicators. Let's start by looking at the pyramid illustrating data requirements for calculating different levels of energy efficiency indicators. The top of the pyramid represents the commonly available data, like energy balances. They allow calculating aggregated indicators such as energy intensity or the energy consumption per capita. This level of indicators give a general idea of the macro trends. However, it's not sufficient to conduct in-depth energy efficiency analysis. The middle part of the pyramid refers to the higher data needs in terms of data disaggregation, such as energy consumption by end use. As examples of indicators from this level, we could name energy consumed to produce 1 ton of steel or the energy consumed to heat 1 square meter of a building. Finally, at the bottom of the pyramid, the data requirements are the highest, going even to the process level, like a dry process of cement production. Such detailed indicators can be useful in monitoring very specific trends. But what is actually energy efficiency? According to the IEA Manual on Energy Efficiency Indicators, energy efficiency indicator is defined as a ratio of energy consumption namely a sum of all fuels consumed to produce a certain service or commodity, and corresponding activity data. The activity data are sector-specific. It could be a physical production of a certain commodities like cement or steel, floor area, or the distance traveled by a vehicle. Now, I will go sector by sector to show you what type of energy consumption and activity data can be useful to create energy efficiency indicators. Let's start with residential sector. In order to calculate energy efficiency indicators for residential sector, the IEA recommends collecting energy consumption data by end use, namely energy consumption of space heating, space cooling, water heating, cooking, lighting, as well as energy consumption of different appliances such as dishwashers or televisions. It is also important to collect data on heating degree days and cooling degree days in order to correct space heating and space cooling energy consumption for the year-to-year variation of the temperature. In other words, when we analyze energy efficiency indicators for space heating and space cooling, we want to observe changes in energy consumption resulting from the energy efficiency improvements, and not from the milder or heavier winter. In respect to activity data for the residential sector, one could collect information on the number of dwellings, residential floor area, as well as stock of different types of appliances. And now, small exercise to revise what we have just seen about energy efficiency indicators for residential sector. On the left side, we have energy consumption for space heating and space cooling. On the right side, two options of the activity data. In this case, residential floor area is the most appropriate activity data because we are heating or cooling in reality the space. When it comes to the energy consumed for water heating, the better option is the dwelling or number of dwellings, because we don't need more water because our house is bigger. It relates to the number of people living there. And finally, the last example of appliances energy consumption. In this case, we want to have some additional data, namely appliances stocks. It will allow us to calculate average unit energy consumption of dishwashers and televisions. And now let's have a look what we can do in terms of data collection for services sector. In terms of energy consumption data, we can collect data for space heating, space cooling, lighting, other building uses and non-building uses like streets lighting. As for activity data, we could look at the value added, services floor area, or number of people employed in services. The next sector is industry. Here, IEA collects data for 19 major ISIC subsectors by fuel type. For activity data, we collect value added, and for the homogeneous energy intense sectors like cement, we collect also physical production in tons. When it comes to ISIC 19 subsectors, we look at chemical sector, iron and steel, non-ferrous metals, and so on. But it's also good to have a look at much more detailed data like aluminium, cement, clinker, or even going further for pulp, for chemical pulp, mechanical pulp, and so on. And finally, the last sector, transport. It may seem a little bit more complicated because here we are looking at energy consumption by segment, namely passenger or freight, as well as transport by mode, and here road, rail, air, and water. When it comes to activity data, we focus on vehicle stocks, distance traveled, and occupancy or load, depending on that whether we are talking about passenger transport or freight transport. Based on them, we are able to calculate passenger kilometers and ton kilometers. The general definition of energy efficiency in transport is transporting more people or goods at a further distance with less fuel consumed. And now, there is a question for you. Is it more efficient to use public transport or personal cars? I suppose most of you would answer that public transport. And in normal condition, you would be totally right. But what if in your country all buses are almost empty and all passenger cars are running like that? This short example should underline the need of really good activity data to understand what is actually happening in your country and whether this system is efficient or not. And now another example, how to calculate activity and structure data. We'll look at stock of vehicles, vehicle kilometers, passenger kilometers, and ton kilometers. Let's imagine that we are in Paris and we want to move from the Cathedral Notre Dame de Paris to Eiffel Tower. We assume that the distance is 5 kilometers and we have two vehicles, a boat and a car. In a boat there are 4 people, in a car 2. Now let's calculate together vehicle kilometers, passenger kilometers, and average occupancy. Vehicle kilometers is the distance traveled by all vehicles in the system. Here, a boat and a car moved by 5 kilometers. So twice 5 kilometers give us 10 vehicle kilometers. For passenger kilometers, we want to know how far all passengers traveled. Therefore, we multiply 6 passengers times 5 kilometers and we get 30 passenger kilometers. Finally, average occupancy or average load is calculated as a total number of passengers divided by total numbers of vehicles, or passenger kilometers divided by vehicle kilometers. In both cases, we will receive 3 passengers per vehicle. Now we came back to the slide that we have seen before to underline that always both energy consumption and activity data involve a certain uncertainty that affects our energy efficiency indicator. In the next section, we would like to talk about how to collect energy efficiency data and what kind of methods or tools we could use to create these data collections, both for energy end use and activity. In 2009, IEA agreed on the energy efficiency data collection and afterwards developed a questionnaire based on the cooperation with many international communities. Our questionnaire is an Excel user-friendly template that is available online. It covers both energy consumption and activity data for 4 sectors: residential, services, industry, and transport. Last year, for the first time, energy efficiency indicators data were published in form of a report called Energy Efficiency Indicators Highlights. They are available at the IEA website for free. But what kind of methods we can use to collect data at the country level? First of all, before starting any data collection, it's good to make sure that this data is not already collected by someone. If it's not the case, you can consider creating a new survey. However, often it's much less expensive to expand already existing surveys. When it comes to measuring and metering, it's a very expensive way of data collection. However, it gives very detailed information and often can be very useful. Modeling can be both complementary to existing survey or stand alone, and it's widely used. All of these methods are mentioned in the manual on fundamentals of statistics. This manual provides a guidance on how to collect the data needed for indicators and includes as well a compilation of existing practices from across the world. IEA developed as well another manual that is dedicated for policymakers. It provides some guidance how to develop and interpret energy efficiency indicators. Both of these manuals are available in English, Spanish, Russian, and Chinese. Another thing that IEA developed in order to share experience across the world is an online database where countries' practices from over the world are shared and they are available for free. You can search by sector, by methodology, and available content. It means that some countries decided to share their questionnaires with you. It is a very powerful tool to start a new data collection because you can learn from experiences from different countries. If you have any data collection practice that you would like to share with us, don't hesitate to contact us. And finally, some main key messages from the presentation. First of all, detailed end-use energy consumption data and activity data are crucial to monitor energy efficiency. Always, you need to look first at the priority sectors. You can try with them, understand better trends, and you can monitor policy effectiveness. It is important also to raise awareness about data needs, as well as adapting data collection to the profile of your country. Please share as well experience from your data collections and learn from that what is already online. If you want to learn more about the IEA energy statistics, we have a lot of different resources that can be helpful. You will find below the links for our energy statistic manual, which is a comprehensive manual available in 10 languages. You can also visit the IEA statistic website for a wealth of resources, including our questionnaires, glossary, and documentation related to our data collection methodologies. Also, you can have a look at the United Nations International Recommendations for Energy Statistics, which provide a methodological framework for our work in energy statistics.